Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim.
Allahumma salli ala sayyidina wa maulana Muhammadin wa ala ali sayyidina wa maulana Muhammadin wa barik wa sallam.
Assalamu alaikum dear students. Today we will discuss about electric current. Before starting the topic, you must keep in mind there are two types of charges known as positive charge and negative charge. Proton is positively charged and electron is negatively charged. Another thing, whenever the current passes through any conductor, only electron flows. Positive charge or proton never flows. Let's start now. The electric current is defined as the rate of flow of charge in a metallic conductor. Dear students, rate means per unit time. So we can also define the current as the flow of charge per unit time in a metallic conductor. Another definition for current, as we have discussed, only electrons flow. So current may be defined as the rate of flow of electrons in a metallic conductor or the flow of electrons per unit time in a metallic conductor. The word equation for current is equal to charge over time. Mathematical formula for current is the current is represented by a letter I, charge is represented by a letter Q, the Q may be small or capital, and time is represented by a letter T. So mathematical formula for current is I is equal to Q over T. The SI unit for current is ampere. The current through any metallic conductor is 1 ampere if 1 coulomb charge passes through that conductor in 1 second. So ampere is coulomb per second. Let's discuss an example. If 12 coulomb charge passes through any conductor in 3 seconds, find the current in ampere. To find the current in ampere, we use the formula I is equal to Q over T. Here Q is 12 coulomb and time is 3 seconds. So our answer is 4 coulomb per second. 4 coulomb per second means 4 ampere. 4 ampere means 4 coulomb charge is passing through that conductor in 1 second. So ampere is coulombs per second. How much charge is passing through any conductor in 1 second? That is equal to ampere. Next, the instrument used to measure current is ammeter. This is the symbol used for ammeter. Regarding ammeter, you must keep in mind, number 1, ammeter is always connected in series, and number 2, ammeter is a low resistance device. The resistance of the ammeter is kept lowered so that its resistance should not affect the flow of current in a circuit. Now we will discuss about conventional current. Conventional current is defined as the current which flows from positive terminal of the battery to the negative terminal of battery. In simple words, we can say that the current which flows from positive to negative is called conventional current. The current which flows from positive to negative is called conventional current. To understand the concept of a conventional current, we will discuss an example. In this example, we have 3 red baskets and 3 green baskets. Red basket has a ball, but the green baskets are empty. Here the ball represents the electron. To understand the concept, we suppose that the ball represents the electron and there is a deficiency of ball in the green basket. Statically, we know that the deficiency of electron is called positive and presence of excess electron is called negative. As we have considered a ball as an electron, so red baskets are negatively charged. Red baskets are negatively charged and green baskets are due to deficiency of electron or ball are positively charged. Now if we shift the ball from red basket to the green basket, it means that the electrons are moving from negative to positive. It means that electrons are moving from negative to positive. When all the ball has shifted to the green basket, now the red baskets are empty. As we have said, the empty baskets, there is a deficiency of electron, so the red baskets now become positive and green basket, due to presence of ball or presence of electron, become negative. From this example we can conclude that as the electron means ball moves from negative to positive, from red basket to green basket, the deficiency of electron moves from positive to negative. The deficiency has shifted opposite to the flow of electron. So in a current, actually the electron flows, and electron always flows from negative to positive. This causes the deficiency to shift from positive to negative. If we focus on the flow of deficiency, that is our conventional current. In simple words, we can say that the shifting of deficiency is our conventional current, which took place from positive to negative. Next we will discuss the types of current. There are two types of current. Number one, DC, which is direct current, and number two, AC, this means alternating current. Now first we will discuss direct current. The direct current is defined as the current which flows only in one direction, or we can say that the current which does not change its direction is called DC or direct current. As the DC have only a single direction, so DC is also known as unidirectional current. Unidirectional means one direction. Direct current flows only in one direction. It does not change its direction. Next, the DC current has zero frequency because it flows only in one direction. That's why its frequency is zero. Or direct current can be stored in a chargeable battery or in a chargeable cell. Now we will discuss the graph for DC. The first graph as shown in the diagram, it is a horizontal line. Horizontal line shows its magnitude is constant. This graph is for pure DC. In second graph, in this graph the value of current remain positive but its magnitude change. Positive means there is only one direction. but its magnitude change from 0 to maximum and maximum to 0, or we can say its magnitude fluctuate because it has only positive value or single value. That's why this is also a DC, but not pure DC because its magnitude is changing with time. The third graph is similar to the second one. It has all positive values, so this is also for DC. Now we will discuss alternating current. The alternating current is defined as the current which changes its direction after fixed interval of a time is called alternating current or AC. The alternating current has two directions. It flows forward direction, then backward. As it has two directions, so this is also known as bidirectional current. Bi means two. It has two directions, forward and oppositely backward. This graph is a sinusoidal wave. For the first cycle, its value remain positive, and for another half cycle, the second half cycle, its value is negative. Negative value shows the change in direction. Negative is opposite to the positive. In houses and factories, we use alternating current. The frequency for that current is approximately from 50 Hz to 60 Hz. Alternating current cannot be stored. If we want to store the current, we have to convert AC into DC, direct current, by using a rectifier. Now we will discuss how can we find the number of electrons if a current is passing through any conductor. To find the number of electrons, we have a formula Q is equal to NE, where Q is a charge, N are numbers of electron, N are number of electrons which we want to find, and E is charge on one electron. Its value is 1.6 10 raised to power minus 19 coulomb. Mathematical formula to find the number of electron is N is equal to Q over E. But if current is given, time is given, and charge on one electron is given, we will modify this formula as we know that the current is equal to Q over T. I is equal to Q over T. From this, if we want to find Q, Q is equal to I into T. Q is equal to IT. If we put the value of Q in the above formula, we have N is equal to IT over E. This is another formula to find the number of electron. If current is given, time is given, and charge on one electron is given. Now we will solve a question. The statement of question is: find the number of electrons if 6 coulomb charge is passing in a conductor. Charge on one electron is 1.6 10 to the power minus 19 coulomb. In this question, Q is given, which is 6 coulomb, and charge on one electron is given, which is 1.6 into 10 to the power minus 19 coulomb. So by using formula, N is equal to Q over E. Q is 6 coulomb and E is 1.6 into 10 to the power minus 19 coulomb. Our final answer is N is equal to 3.75 into 10 raised to power 19 electrons. This means if 6 coulomb charge is passing through a conductor, so at that time 3.75 into 10 raised to power 19 electrons are flowing through that conductor. Dear students, today we have discussed about an electric current, its SI unit, its formula, instrument used to measure current, types of current, conventional current, and finally we find the number of electrons when current is passing through any conductor. Inshallah, in next lecture we will discuss about EMF, potential difference, resistor and resistance. Thank you. Allah Hafiz.